this is a publicly broadcasted presentation. I would like to start with a small overview of our multi-body solutions that we offer here at Altair. So you can build your, on the left, starting on the left, you can build your multi-body models either in Motion View and Inspire Motion. Both products use MotionSolve under the hood to simulate the system. Further than to the right, you can then see you can evaluate your results then either with HyperWorks or in Inspire. And lastly, you can improve your design by either running a DOE or optimization natively, or connect it even with HyperStudy. Now, what can you do with Altair MBD solutions? You can do a kinematic study to, for example, study the motion of an end effector of a robotic arm. You can do dynamics to study, for example, the loads on a landing gear system during touchdown. You can also perform a static and quasi-static analysis, for example, to determine the compliance of a suspension system, extract loads for durability analysis or study the low frequency NVH, and also perform a co-simulation with other Altair products for multi-physics simulations. Coupling, we support coupling, for example, with Activate, EDM, OptiStruct, and AccuSolve, and there are a few more. Okay, now let's dive into what we have for Motion View / MotionSolve and its solutions in release 2022. We have a few exciting new features and enhancements. For the next half an hour, Scott and I will go through some of them, some of these improvements. Here's just a summary for the Motion View Solve and the verticals. Most notably, we have a new interface for Motion View core performance improvements, a few improvements for the ground vehicle solutions. Specifically, I'm very excited about the Altair soft soil model, as well as road solutions from partner products. And then also MS-EDM coupling is a feature that got a lot of attention in the past 2 years, and we put more effort into improving it. Let's start off with Motion View core performance. The Motion View team worked hard to improve the model view controller pattern to accelerate Motion View's core. This resulted in a 10 times faster load capability for large assemblies such as vehicles, airplanes, or heavy equipment. The improvements can be also felt for even smaller systems, and you can see a load up time of about 2.5x. Furthermore, also you should experience a 1.5x faster model editing capability. So the overall value is obvious. It's just a better user experience using Motion View now. Here's just a little demo that shows you the differences in the loading time of a vehicle model. Okay. Also, HyperWorks is continuing to transition to the new interface, and Motion View is getting a makeover as well during this process, while also being integrated closer into HyperWorks application. In 2022, the interface comes with new workflows for creating points, markers, and joints. Also, the MV team embedded new features such as move tool and rigid groups, as you can see on the upper right diagram. There's also a new live animation. In previous versions, the solver would be running offline only, meaning Motion View creates an input deck and sends it to the solver. In the new Motion View, Altair's MotionSolve can then directly interact with Motion View itself, meaning you can then see the animation as the simulation runs. Right now, this is only available under beta feature, so you need to use an environment variable called HW live animation equal to 1, as shown down here. This will provide you access to the live animation. Finally, finally, also the more and more entities have now transitioned to entity editors. Or having the entity editors. As we transition with this process, more panels, or the old style of the panels, are being now converted with the new interface paradigm, and eventually by the end of this year, all old panels will be removed altogether. Then we have also a translator for Vortex Studio from CM Labs. CM Labs is an Altair partner. Vortex Studio is a real-time simulator for human-in-the-loop testing. Let me see if I can show the animation. So motion view models can now be directly exported to Vortex Studio. And over there, it can then be augmented with a realistic environment and connected to a physical controller such as the joystick. Let the video play out. Advantage here is, of course, your vetted motion solve model can then be reused for real-time simulation and visualization. So you would do a detailed model first in motion view, run it with motion solve, finalize your initial design, and then bring it to Vortex in order to perform real-time simulations such as human-in-the-loop testing. This will overall then also accelerate the design cycle and bring user experience into the design early on. Now, based on customer feedback, we also improved our coupling to EDEM. EDEM is a bulk material simulator by Altair based on discrete element method. One enhancement is the transfer of labels from motion view to EDEM, as you can see it here. That allows you to better identify, correlate, and compare graphics between EDEM and motion view. Another enhancement is the support of save and reload. So now you can save your co-simulation results in user-specified intervals. This allows you then to restart a simulation from a time, let's say, greater than 0, and is really helpful if, for example, a simulation crashed in between because of network issues or other issues, or the model needs to be modified in between. So EDEM itself is, of course, computational, much more expensive, and you want to avoid rerunning a simulation always from the start. Now, coming to the ground vehicle solutions, we have a new event for two-wheelers. Our motion solutions are growing significantly in the scooter and two-wheeler industry. And there, to understand the stability of a vehicle plays an important role in the design phase, specifically to wobble and weave. And so the new event that we added for two-wheelers allows you then to perform either a linear or transient simulation. Using the linear analysis approach, you can look at the mode shapes and the respective natural frequencies directly, or using a transient analysis approach, where after the transient analysis, a report will be automatically plotted, providing you steering, yaw, and roll angles in the time domain as well as in the frequency domain. Of course, you need to excite the vehicle. You can do that by, for example, short impact force or moment at any location on the vehicle, and then you will see the wobble or weave mode. Then also for the past several years, we partnered with the Lab for Machine Dynamics at the Aristotle University of Thessaloniki in Greece. And in the past 2 years, we are building together a new empirical-based soft soil tire model explicitly for motion view, motion solve. The tire includes a single point or cam contact Fiala formulation. On the other hand, the soft soil is derived from the Becker-Wong formulation, and then combining these two results in a very fast simulation of tire-soil interaction. Furthermore, also we have 9 predefined soil models to simulate the vehicle on dry sand all the way to heavy clay. This will give you then a good initial start with your design. And of course, you can then also provide user-specified soil data if you need to refine your simulation. As you can see, the animation also includes ground syncage, which allows you then to quickly validate your simulation. We believe that this new tire model is particularly useful for early design studies. For more detailed simulation, you can then transition to a motion solve in EDM coupling or co-simulation. Here you see another example of the new tire soft soil interaction. As a truck drives on a sand bed, it performs a counterclockwise steering driving maneuver. And because of the leaning outwards from the curve, you see that on the right side, the soil is getting compacted heavier than on the inside. And you also see that the left front tire is slipping. Another enhancement is the ability to change pressure for the CD tires mid-simulation. Now this allows you to simulate scenarios such as a tire blowout and investigate how the ESP or ADAS would handle such situations. This is a project with one of our partners. Quick intro to A+ IDIADA. IDIADA provides services to the automotive industry for over 30 plus years and joined recently the Altair partner program. One part of the offering is a comprehensive ground in Spain that is being used by various OEMs. And 24 of the scanned road sections can now be integrated into motion view / motion solve for even faster design cycle. Similar to IDIADA, we also include 9 roads provided by Xenomatics. Xenomatics also joined recently the Altair Partner Alliance. They build true solid-state LiDAR sensors based on a multi-beam laser concept. And using Xenomatics products or service, you can then create a virtual representation of your own test track and import them into motion view / motion solve for further analysis. The tire test rig has been enhanced as well. In addition to the lateral, longitudinal, and vertical test, you can now also simulate combined slip tests. For that, you will obtain a lateral versus longitudinal force diagram, or also referred to as a GG diagram if the forces are normalized. This will help you then in assessing the limits of the tire based on multidirectional forces. And then finally, the end post test rig has been expanded with a new report. the report opens a new HyperWorks session and displays the animation of the event, as well as various plots with primary information such as vehicle body and steering accelerations and wheel and actuator forces. Advantage is that you don't have to create these diagrams manually anymore. At this point, I would like to transition to Scott.
So I'm showing my screen here. So thank you for your time, everybody. First off, I'd like to thank the Inspire Motion development team for all their hard work in turning out another great release here. So what we'll look at today are some of the new features and enhancements and improvements. Some of the new features we have, one of the biggest thing are state-dependent inputs, where we can control the input as opposed to keeping something dependent on time. It can be dependent on the state of another input or an occurrence in the model. Proximity measures, we can determine whether parts have a finite clearance between them, if they're interfering, or if they're touching. We also have a tool called intersection detection for contacts, where it allows us to see if parts are initially overlapping between each other. And then we have active contact iteration. This was a motion solve implementation. This is also on the motion view side. So motion view in this release is also going to have this feature. So we'll talk a little bit about that. And then some of the additional enhancements and improvements we have around some of the existing features in Inspire Motion. So first off, we have state-dependent inputs. And what state-dependent inputs do is they allow us to model an extended range of applications that are not just in the time domain. So as you can see, we can now model things such as torque versus speed, force versus angle, force versus distance, etc. We can also create a cycle. For example, in a 4-stroke piston engine, one complete cycle is 720 degrees. So we're able to specify what defines a cycle in terms of cyclic rotation. Some additional examples here for state-dependent inputs. You can see that the force on the blade on this reciprocating saw is a function of the rotation of the drive gear. And then over on the right here, sort of a fun example, but just demonstrating the feature, how there's a force applied to these other spheres here that's a function of the distance between the black sphere and each of the other spheres. This is a snapshot of what the user interface looks like for state-dependent inputs. And it's a fairly straightforward workflow, as you see labeled here with steps 1 through 4. So now we have in the micro dialog an additional option here. So we'll specify if we're using time or if we're using another object as the variable. We have a variable object selector. So once you define the state-dependent or the input's going to be dependent on a variable, you select the object on the screen. Currently, we support motors, actuators, linear and angular measures, as well as systems. In the future, we may expand this to other objects. Step 3, we activate the profile editor, and you can see here this is different from what we're used to looking at for the time-dependent profile editor. Specifically, we now have different references. We specify the variable we're using. We specify the reference frame because there are different reference frames for the different frames for the different objects. And then we specify the different component for this variable, what we're going to use as the variable lookup. And there's we can access library of functions here. And then we specify the input range and then the force range for the actuator in this example. And then we can see the preview of these in the plot. Next feature we have are proximity measures. So they allow us to monitor the minimum distance between parts at any time during the motion simulation. And the endpoints of the proximity are colored according to the condition. So blue means the parts have a finite distance, yellow means they're touching, and red means they're interfering. We can also see through the state plot here that whenever there's an interference, this will go up to a value of 1. So anytime it goes from 0 to 1 on the state plot, we see that we have interference between the two parts. The next feature we have are initial intersection detection for contacts. This is an additional feature we added onto the contacts guide bar that allows you to cycle through the model and see where you might have initially intersecting parts. Why? Because this can sometimes be problematic for simulations in which parts are unknowingly overlapping. So when you start the simulation, it can present problems. It can also present some errors in convergence and the results. So with this tool, we're able to step through and accept those interferences, or we can stop here and make a geometry change to correct them. If we don't use this tool right here to check for the interferences, and we have contacts defined, if we go to run the simulation, we'll get an error message or a warning message that tells us that we have intersecting conditions. Next, we have active contact iteration. Again, this is in motion view as well. And this is basically where you can see quite a bit of a difference here in the results. So basically what it's doing is helping to reduce the noise. It's performing extra calculations, if you will, refreshes on the iterations through each time step. And through most of the experimentation here, either the simulations run faster and there's no difference in the results, or there's a difference in the results and they run faster. So the output from this, the feedback has been pretty positive. You can see here the difference in these models are identical, and look at the difference in solve time, 8 seconds versus 55. So I think this is going to be a substantial improvement on many of contact models of certain types. We've also improved the coupler display. Previously, we had sort of colored two-dimensional circles. Sometimes it was not clear on which side was scaled to which value. We now have a 3D graphic, as you can see here in these pictures labeled 2022, and we now label the scale on here so it's clear to the user as to which side is getting which scaled ratio. We've made improvements to the contacts guide bar in terms of the workflow. Previously, these buttons didn't have much logic in them. If you were navigating through existing contexts, the filter was still active and things like that. So we've built in more logic that is really identifying what the user is doing. Are they editing an existing contact, or are they creating one? And so with that in mind, what we do then, if we're navigating existing contacts, we don't show, or we deactivate the filters, for example. In the past, these two arrows on the far right had two different purposes, but now we've broken them down into one purpose. And the only purpose is to navigate existing contacts. And then here we have another set of arrows, these are new, that allow us to place objects based on the filter into the respective part groups. And we also have this individualize. Previously, we auto-checked the individualize. It's created some confusion from users, so we've deselected it. So now we let the user at will choose when they want to individualize one contact and break it into multiple contacts. We've made various improvements to the handling of flexible bodies. First off, we are now caching the flexible body. In the first release we had with flexible bodies and Inspire Motion, it was reusing or recreating the flex body each time you went in to run a flex analysis. So this was fairly inefficient. So now we're caching the H3D or the flex body, and it's only regenerated if there's a change to the part itself or any of its boundary conditions. In addition to frequency cutoff, we've also now added a maximum frequency option here for specifying the number of modes to include in the CMS flex body creation. Flex body results are now loading faster. We've improved it, so now we're loading them 2.5 to 3 times faster. This is a substantial improvement from what we were doing in the initial release here with flex bodies. And then finally, we've modified or added a flexible body icon representation for the part. So if you have a part that is flexible in the model, not only will it show as a light blue on the graphics window in the geometry, it'll also show a new icon next to the part name. We have some new result outputs for plots. And the main reason these result outputs were put into place is because of the introduction of state-dependent inputs. Now users can first run a base simulation. They can create a plot, for example, of the travel. And with this plot, then they can identify at what point they might want to trigger the input. So remember, we're using variables such as the measure travel to create a cycle or an input for an actuator or motor. And so a user can identify at what point they want to create that trigger, and then they can use these values inside of the state-dependent profile editor. So we have some new outputs for displacements. They're now relative to 0. They were previously presented in global position coordinates. And we also have rotations cyclic and rotations total. Some users have been asking about the ability to be able to say, count the number of cycles in the model like this, for example. So that's another area where this can be helpful in addition to providing data for state-dependent inputs. And then also we have a new measure, our new travel measure for or travel output for measures where the initial value is always starting from 0. Previously, it was the distance between the two parts, but for state-dependent inputs, it was not conducive for creating that variable reference. So we've sort of tailored these outputs better to suit these new state-dependent inputs. And then we have some plot manager improvements. So first off, now we can multi-select objects in the plot manager, and we can right mouse button and plot any component that is common between these objects. So if these objects are of the same class, whether it's a spring, a joint, a contact, we can multi-select using your control or shift key, and then you can batch plot like you see here. We also have graphic selection or selecting from the plot manager. So if you're inside the plot manager, you can click on an object in the graphics area, a part, for example, and it will create the plot in the plot manager. It did not do this previously. And then finally, if you have a callout plot, these are the plots that you create when you select a part after it runs a motion analysis, and you can quickly see just a basic plot. And it looks like it has a flag connected to it. Well, if you then enter the plot manager and there's an empty page, it will automatically transfer that plot as the first plot in the plot manager. So you don't have to recreate this plot. Okay, so with that said, I'm going to pass it back to Adrian for a summary on this.
Thank you very much, Scott. That was fantastic. So as you could see, we had general improvements, such as the live animation in Motion View or the plot manager in Inspire. We have new features for our ground vehicle solutions, like the road models for cinematics and EDADA, the new tire soft soil model, and stability events for two-wheelers, improved coupling between MotionSolve and EDM. Also, as Scott mentioned, we have now the state-dependent forces that helps in many different applications. Improved model insight in Inspire as well, particularly in respect to the proximity sensor that shows you clearance, contact, and interference. And then also general performance improvements within the solver engine itself, particularly to rigid body contacts that are big benefits for Inspire as well as for Motion View. And also Motion View itself got a good workover in order to improve its core performances to load data and edit data. With that, I would thanks everyone.